Welcome to Math 9 class with Mom MC. I hope this day will be another day full of learnings for all of you. Today's lesson is about quadratic functions. I will be discussing your MATHPACKS for grade 9, quarter 1, week 6. Here are the objectives for our lesson. At the end of our lesson, you learners will be able to model real-life situations using quadratic functions, and you will be able to represent a quadratic function using table of values, graph, and equation. Since our topic focuses on quadratic function, let us define first what is a quadratic function. A quadratic function is a function that describes a polynomial of degree 2. It is defined by y equals ax squared plus bx plus c, where a, b, and c are real numbers and a must not be equal to 0. So it's somewhat similar to our quadratic equation, only here in quadratic function there are two variables which are involved. So a quadratic function y equals ax squared plus bx plus c can be represented by a table of values, graph, and equation. It can also be written as the function of x, or f of x is equal to ax squared plus bx plus c. So the graph of a quadratic function is a parabola or a parabola. The parabola opens upward if a is greater than 0, which means to say a must be positive. So it looks like this one. So notice that a parabola or a parabola is not your typical U-shaped figure or object. Okay? Because kung manotice nyo, as it approaches positive infinity or as it goes upward, ang parabola na to nag-widens. Okay? So if the parabola again opens upward, that means to say a is greater than 0, or the leading coefficient or the coefficient of our quadratic term is a positive number. So it looks like this one. So it looks like an inverted logo of McDonald's. And then the parabola or the parabola opens downward if a is less than 0, which means to say negative. And it looks like this one. Now here are some famous architectures in the world with parabolic structures. We have the oceanographic, which is an oceanarium situated in Valencia, Spain. So this is situated on the dry Turia River, where different marine habitats are represented. So the oceanarium, or the structure of the oceanarium, is similar to a parabolic shape. And then we also have the Gateway Arch in St. Louis, Missouri, US. So it is a 630-foot monument clad in stainless steel. It is referred to as the Gateway to the West. And then we also have the Scotia Bank in Saddle Dome in Calgary. It is a multi-purpose indoor arena built in 1983 to replace the Stampede Corral as the home of the Calgary Flame. So these are some of the architectural places wherein the structure is in parabolic shape. Now here are some application of parabolic shape in science. We have the car's headlight. So the parabolic reflector has the characteristic of reflecting rays parallel to the principal axis when a light bulb is placed at its focal point, irrespective of where the rays fall onto the reflector, and thereby produces a bright parallel reflected beam of constant light intensity. We also have the satellite dish. When a beam hits the curved dish, the parabola shape reflects the radio signal inward onto a particular point, just like a concave mirror focuses light onto a particular point. The curved dish focuses incoming radio waves onto the feed horn, which passes the signal onto the receiving equipment, thus creating a clearer signal. So you see, the parabolic shape is not just used for a beautiful structure, but also it is used for lights and also for good sounds. Now let us have an example. So in order to survive in the difficult times of COVID-19 pandemic, DJ Bait makes a vegetable garden. He wants to put a bamboo fence onto the three sides of his rectangular garden as shown in the figure. If 100 meters of bamboo fence is needed onto the three sides of the vegetable garden, find a quadratic function in standard form for the area in terms of its width. Now this rectangle in dark blue shade is representing or will be representing the house. And this light blue shade or this rectangle in light blue shade will represent the vegetable garden. Notice that one side of the vegetable garden is attached on one edge of the house. So if DJ wants to fence the entire garden, he will only be needing to fence the three sides of the garden because this side of the garden is already attached to the house. So there is no need for him to fence it. Now, these three sides of the garden will be 100 meters long. So this one is the length. The other two sides are the width. So there is only one length, of course, and two width because this length here is part of the house. Now, we will be getting the representation or a quadratic function that will represent the area of our vegetable garden in terms of the width. So we will be using W as our variable. If we let L represents the length and W as the width of the rectangular garden, the expression for the sum of the measures of the three sides of the vegetable garden will be length plus 2 width equals 100. Remember, we only have three sides to be fenced since one side of the garden is already taken as the edge of the house. It's already part of the house. So there is no need to fence it. Now, length plus 2W or L plus 2W is equal to 100. The length of the rectangular garden in terms of its width will be L equals 100 minus 2W. So we got this equation from here. We will be omitting 2W or we will be removing W to this side or from this side of the equation. We will be adding both sides of the equation by the additive inverse of 2W, and that is negative 2W. Add the side by negative 2W, we will only have L. And then add the side by negative 2W, we will have 100 minus 2W. So we simply have to transpose 2W to the other side of the equation. And by doing so, 2W will be negative. So length in terms of W or length in terms of width is equal to 100 minus 2W. We will be forming the quadratic function. So formulate the area in terms of the width. We are asked to find the quadratic function that will represent our area or the area of the vegetable garden. Area, remember, is equal to length times width. So the area in terms of width equals length times width. This is the formula in getting the area of any rectangular shape or any rectangular figure. So area is equal to length times width. A of W, so length, remember, is 100 minus 2W. So we replace this length by 100 minus 2W. So this is the representation of our length in terms of our width. And then width, of course, is represented by letter W. So area of the rectangular garden or of the vegetable garden equals the quantity 100 minus 2W times W. Then we simplify. We multiply W to the binomial. So W times 100 equals 100W. W times negative 2W equals negative 2W squared. This is now our new area. Area in terms of width equals 100W minus 2W squared. Then we will just interchange the position of 100W and negative 2W squared so that our quadratic term will come first. So negative 2W, take note, the operation on the left side of any expression is their sign. So if on the left side of 2w squared is a minus sign, then we take this minus sign as the sign of 2w squared. That is why we have negative 2w squared. And as for the 100w, since you cannot find any sign in here, that means to say 100w is positive, so that is why we have plus 100w. So area in terms of width equals negative 2w squared plus 100w. Thus, the area of the rectangular vegetable garden in terms of its width is A of w equals negative 2w squared plus 100w. And this is now our final answer because we are only trying to get the quadratic function that will represent the area of our vegetable garden. We don't need to solve it, okay? Just for this situation or just for this problem. Now, a quadratic function y equals ax squared plus bx plus c can be represented by a table of values. In making a table of values, assign values for x and then solve the corresponding values of y. The table of values for a quadratic function shows equal differences in x produce equal second differences in y. So we will be representing our quadratic function through the use of table of values, and we will be determining whether a particular table of values represents a quadratic function or not. Now let us have an example. Construct a table of values representing the quadratic function y equals x squared minus 2x plus 1. In making a table of values for a quadratic function, it is suggested to have at least 5 ordered pairs, x, y, satisfying the given function. Hence, let us assign x equals negative 1, 0, 1, 2, and 3. Now, here is your table of values. So, for the x, we are the one who will be assigning for the values of our x. X are the independent variables. Okay? So, kita ma-assign ka na dyan. And then, your y is the dependent variables. The value of our y depends on the values of the x. We will be substituting each value of x into our quadratic function to look or to determine the values of our y. So first, let's have negative 1. So given the assigned values of x, solve for the corresponding values of y. Now if x is equal to negative 1, we substitute negative 1 into our quadratic function. So every x here will be replaced by negative 1. That is why we have y equals, so you copy y equals, x squared will become negative 1 quantity squared. Enclose negative 1 into a parenthesis. That is to denote that negative 1 is being squared. The entire negative 1, not just the 1. Then minus 2x. Minus 2x is minus 2 times negative 1. And then add 1 or plus 1. Copy plus 1. Negative 1 quantity squared is equal to positive 1. Negative 2 times negative 1 is positive 2. Positive 1 plus positive 2 equals positive 3 plus 1. So positive 1 plus 2 plus 1 equals positive 4. So if x is equal to negative 1, y equals positive 4. So our first ordered pair is negative 1, 4. Now if x is equal to 0, the same thing will happen. We will be substituting 0 into this quadratic equation. So we will be replacing every x here by 0. That is why we have y equals 0 squared minus 2 times 0 plus 1. 0 squared is 0. Negative 2 times 0 is 0. So what is left is 1. So if x is equal to 0, our y is equal to 1. So our next ordered pair is 0, 1. Next, what if x is equal to 1? So if x is equal to 1, then y equals 1 squared minus 2 times 1 plus 1. 1 squared is 1, minus 2 times 1 is 2, so that is 1 minus 2, and that is equal to negative 1. Negative 1 plus 1, that is equal to 0. So if x is equal to 1, then y equals 0. Next ordered pair is 1, 0. Now what if x is equal to 2? If x is equal to 2, then y equals 2 squared minus 2 times 2 plus 1. 2 squared is equal to 4, minus 2 times 2 is equal to 4, so that is 4 minus 4, that is 0. What is left is 1. So if x is equal to 2, our y is equal to 1. So the next ordered pair is 2, 1. Now if x is equal to 3, if x is equal to 3, then y equals 3 squared minus 2 times 3 plus 1. 3 squared is equal to 9. 2 times 3 is equal to 6. So 9 minus 6 is equal to 3 plus 1, that is equal to 4. So if x is equal to 3, our y is equal to 4. So the last ordered pair is 3, 4. Now this is now our table of values. These values of x again are assigned. And then these values of y, we get this after substituting each value of x into our quadratic function. That is why we say this is a dependent variable, because the value of y depends on the values of our x. Determine whether the given table of values represents a quadratic function. Now, how do we determine whether a particular table of values represents a quadratic function? Now, take a look at the previous table of values that we have. We have obtained the values of y by substituting these values of x into our quadratic function. So we are assured that this table of values is a representation of quadratic function. But let us check. What if you are only given table of values? So how do you know that it is indeed a representation of a quadratic function? So first, try to look at the values of x. We will be getting the differences between the values of our x. That means to say, we will be getting the difference between 0 and negative 1. So it's either you subtract negative 1 by 0 or you subtract 0 by negative 1. So pwede negative 1 minus 0 or 0 minus negative 1. Either way, just as long as kung ano ang plus star sa una, amo wala dapat sa succeeding. So if you subtract 0 by negative 1, it should be 1 minus 0, 2 minus 1, 3 minus 2. Okay? So 0 minus negative 1, minus ron, negative pa si 1. So minus and negative become positive because negative times negative is positive. So it's 0 plus 1. So 0 plus 1 is equal to 1. So the first difference is 1. What is 1 minus 0? So 1 minus 0 is still 1. What is 2 minus 1? So it is still 1. What is 3 minus 2? It is still 1. So there is a common difference between our x. Okay, and that is equal to 1. So for the x, we need to get the first difference. The first differences of our x values must be equal to each other. Okay, so this is how it looks like. So that is why as much as possible, we use values of x which are close to each other or kumbaga pasunod so that we will have the common difference. And then for your y, first we will be getting the first difference. So we will do it 4 minus 1, 1 minus 2, 0, 1, 0 minus 1, 1 minus 4. Okay? So 4 minus 1 is equal to 3. 1 minus 0 equals 1. 0 minus 1 equals negative 1. And 1 minus 4 equals negative 3. Notice that the differences are not equal. These differences are the first difference for this quadratic function. Now, it's okay if the first differences are not equal. Okay? Because we are dealing with quadratic function. What is important is that after getting the second differences, dapat equal sanda. Diyan kita ma-determine whether our table of values represents a quadratic function. If the second differences are equal. So, for the second differences, we will be getting the difference between the first differences. So, we will say 3 minus 1, that is equal to 2. 1 minus negative 1. Minus row negative pa, so that will be positive 1 or plus 1. So 1 plus 1 equals 2. And then negative 1 minus negative 3. So minus negative, simimo ta na plus 3. So negative 1 plus 3. And that is positive 2. So notice that the second differences are equal to each other. So if the second differences are equal to each other, then we can say that this table of values represent a quadratic function. So in the given table of values, the differences in x here are equal. So 1, 1, 1, 1. And the second differences in y are also equal. 2, 2, 2. It shows that equal differences in x produce equal second differences in y. Thus, the given table of values represents a quadratic function. Now, what will happen if sa first difference pa lang equal ron? If sa first difference pa lang equal ron, then we can say that is not a quadratic function, or this represents not a quadratic function, but linear function. So, kung first difference lang sa aton nga dependent variable, which is y, then we can say that is a linear function. But if ang equality ma-appear sa second differences sa aton yung y, then we can say the table of values represent a quadratic function. Parabolas have common characteristics, or parabolas have common characteristics. It is a line called the axis of symmetry, which divides the parabola into two parts such that one half of the graph is a reflection of the other half. So we have here our Cartesian coordinate plane. So this is what you call the Cartesian coordinate plane. We have here the horizontal line is called the x-axis, and then the vertical line is called the y-axis. The point of intersection of these two axes again is called the origin. So the coordinates, or the ordered pair for our origin is 0, 0. Now, for your x-axis, if you are going to the right side of the x-axis, then those are the values which are positive. Taking the values to the left side of the x-axis, we will have the negative values. And then for your y-axis, so if you are going above the y-axis, then we will have the positive values. And then below, we will have the negative values. Now again, a parabola has a line called the axis of symmetry. It divides the parabola into two parts such that one half of the graph is a reflection of the other half. So if this is our parabola and it opens upward, this line here, which cuts our parabola into two equal parts such that this side is a reflection of this side, is called the axis of symmetry. Axis of symmetry is a vertical line. It cuts the parabola into two equal parts such that one half of the graph is a reflection of the other half. If our parabola opens downward, then it will look like this one. And this is still our axis of symmetry. So, a parabola or parabola has a turning point called the vertex. So, kumbaga, this turning point, di dya may U-turn ang aton nga figure. So, the vertex can either be the lowest or the highest point of the graph of a quadratic function. If the parabola opens upward, the vertex is the minimum point. Notice, ang atong parabola or parabola, may arrow. That means to say it is continuous. Masaka, radijang masaka, we don't know where it ends. And then, as well as on the other side, masaka, maradijang. So, this point here, which we call the vertex for this parabola, or for this parabola, this is our vertex. And this vertex is the minimum point because this is the lowest point of our parabola because everything or every value goes upward. So meaning, amo dyan pinaka-nubo. If the parabola opens downward, then the vertex is the maximum point. It's the peak of our parabola. So this is our maximum point. Again, if A is greater than 0, that means to say A is positive, the graph of the parabola opens upward or the parabola itself opens upward. And if it opens upward, the vertex is the minimum point, which means to say if A is positive, the vertex of our parabola is a minimum point. It is the lowest point on your quadratic function. If A is less than 0 or if A is negative, then the graph opens downward. And if the graph opens downward, the vertex is the maximum point. It is the highest point in our graph. To sketch the graph of a quadratic function, here are the following steps suggested. First, construct a table of values for x and y. Second, plot each ordered pair of values on the Cartesian and coordinate plane. And then third, connect the plotted points with a smooth curve and label, of course, the graph. Now let us have an example. Represent a quadratic function y equals negative x squared plus 6x minus 5 using its graph. So again, first step natin, we need to construct a table of values for x and y. Now before we construct the table of values for x and y, notice here that the value of our a is equal to negative 1. Okay? So it's negative 1. So if it's negative or if a is negative, again, the graph opens downward and our vertex is the maximum point of our graph. So we will be expecting later a graph that opens downward and its vertex is the highest point on the graph. So again, we need to construct a table of values. So the quadratic function y equals negative x squared plus 6x minus 5 can be represented by the table of values below. So x is equal to 1, 2, 3, 4, 5, then y equals 0, 3, 4, 3, 0. So again, the values of x are, kumbaga, we decide for the value of x. Okay? And then as for the value of y, we will be getting those by substituting the value of x into our quadratic function. Now this is our table. Again, we are the one who is deciding for the values of x. So x, let's try 1, 2, 3, 4, and 5. Now if x is equal to 1, let's go back to our quadratic function. Y equals negative x squared plus 6x minus 5. So we substitute 1 into our equation. So we copy y equals, and then we copy also the negative sign. Hindi ta nasusulod sang imo nga square. Okay? Your negative value here is not being squared. It's only the x. So leave negative sign outside of your parenthesis if there is any. Now, we copy negative and then x became 1. So that is 1 squared plus 6 times 1 minus 5. So y equals negative 1 squared plus 6 times 1 minus 5. Now, do not enclose it inside the parenthesis since here negative is just being copied. So that means to say the negative sign is not being squared. It's just the 1. Negative, copy, 1 squared equals 1. 6 times 1 equals 6. And then we copy negative 5. So we have negative 1 plus 6 minus 5. Negative 1 plus 6 equals positive 5. 5 minus 5 equals 0. So if x is equal to 1, then y is equal to 0. So the first ordered pair that we have is 1, 0. Next, if x is equal to 2. If x is equal to 2, y equals negative x squared plus 6x minus 5. So y equals negative 2 squared plus 6 times 2 minus 5. Negative 2 squared is 4 6 times 2 is 12, minus 5. So negative 4 plus 12 equals positive 8. Minus 5 equals positive 3. So if x is equal to 2, y equals 3. And that is for our second ordered pair, 2, 3. If x is equal to 3, then our quadratic function will become y equals negative 3 squared plus 6 times 3 minus 5. Negative 3 squared is 9, 6 times 3 is 18, minus 5. Negative 9 plus 18 is... Negative 9 plus 18 equals positive 9. And then minus 5, that is equal to 4. So y is equal to 4 if x is equal to 3. So our next ordered pair is 3, 4. And then we have x is equal to 4. If x is equal to 4, then our quadratic function is y equals negative 4 squared plus 6 times 4 minus 5. Negative 4 squared is 16, 6 times 4 is 24, minus 5. Negative 16 plus 24 equals positive 8. Minus 5, that is equal to positive 3. So if x is equal to 4, then y equals positive 3. So our next ordered pair is 4, 3. And then last one, if x is equal to 5, we have y equals negative 5 squared plus 6 times 5 minus 5. Negative 5 squared equals negative 25. 6 times 5 is equal to 30 minus 5. Negative 25 plus 30 is positive 5. Positive 5 minus 5 equals 0. So if x is equal to positive 5, then y is equal to 0. This will be our last ordered pair, 5, 0. So our ordered pairs are 1, 0. Unahon na to na values ng x. So 1, 0, 2, 3, 3, 4, 4, 3, and 5, 0. We will be needing these ordered pairs to plot on the Cartesian coordinate plane to make our graph or parabola. Now, since we already have the ordered pairs, we are now ready to plot each ordered pair of values on the Cartesian coordinate plane. So, the ordered pairs are 1, 0, 2, 3, 3, 4, 4, 3, and 5, 0. So, 1, 0. So, the first number always is the value of x. So, x is equal to 1, y is equal to 0. So, this is x is equal to 1. So, if we have a positive value of x, then we will be moving to the right side. Kung negative, sa left side. Positive value of y, upward. Negative values of y, downward. So, 1 is here, 0. 0 is here. So, that means to say our first point lies on the x-axis. So, this point here is point 1, 0. Point 2, 3. Our x is 2. So, here, our y is equal to 3. Here, ang tinabuan ng dangadarwa, that will be our point 2, 3. And then we also have 3, 4. So, this is 3. This is 4. So, ang tinabuan ng dangadarwa, ang murang ginatawag nga point 3, 4. So, ang x mo is 3. So, that is 1, 2, 3. And then, ang y is 4. 1, 2, 3, 4. So, this is your point 3, 4. Then, we also have 4, 3. 1, 2, 3, 4. 1, 2, 3. So, this is your point 4, 3. And then, last one, we have the 5, 0. So, 5, 0 is also lying on the x-axis. So, these are the plotted points for our quadratic function. For the step 3, we will be connecting the plotted points with a smooth curve. So, this will be our quadratic function already. Now, this quadratic function or this parabola is the graph of y equals negative x squared plus 6x minus 5. This point here, which we say the vertex, is the maximum point for our quadratic function or for the graph of our quadratic function. Since our a is negative, so our quadratic function or our parabola opens downward. And this point here is called the maximum point, and that is the vertex. And then this line here, which cuts our graph into two equal parts, is called the axis of symmetry. So this is our axis of symmetry, the pink line. And notice that the axis of symmetry passes through the vertex. It touches the vertex. It intersects the vertex. So the axis of symmetry always passes through the vertex, since vertex is also the middle point. Aside from being the maximum or the minimum point, vertex is also the middle point because it is where the axis of symmetry passes. Now, we have already represented the quadratic function using a graph and table of values. This time, we will be focusing on the equation. We will determine whether each of the given equations represents a quadratic function or not. So first, we have y equals 3x minus 7x squared plus 9. Is this a quadratic function or not? So notice the highest exponent of our dependent or independent variable x here is 2. And we have here two variables. So that simply means that this is a quadratic function. So it is in degree 2 and it has two variables involved. Second, y is equal to x squared. So our variable x here has a exponent equal to 2. So which means to say this is still a quadratic function because it is, or this function is in second degree, and of course there are two variables involved. And then for number 3, y equals the quantity x plus 1 times the quantity x minus 1. By looking at this one, you will not really determine whether this is quadratic or not. But by simplifying these two binomials using special product, we will have x squared minus 1. Y equals x squared minus 1. We can see clearly that the variable x here has a highest exponent which is equal to 2. And we have two variables involved. That means to say this is a quadratic function. And then we also have number 4. 0 is equal to negative 3x squared, or the quantity negative 3 times the quantity x squared plus 1. So negative 3 times x squared, that is negative 3x squared rather. Negative 3 times 1 equals negative 3. But since, or this is a quadratic equation, there is the degree 2 in there, or the degree of our quadratic equation is in second degree. But there are only one variable, or there is only one variable involved, which is x. So we cannot consider this one a quadratic function, but rather a quadratic equation. And then last one, we have y equals x cubed plus 1. So obviously, this is not a quadratic function because the highest exponent here is 3. So this is in degree 3. So this is not a quadratic function. So that is how you determine whether each of the given equation represents a quadratic function or not. All you have to do is to look for the highest exponent of our independent variable. If it's 2, then it involves, or after which you will be determining whether the equation involves two variables. If it does, then that is a quadratic function. So that is all for this video tutorial. Thank you so much for listening and for watching. See you again in the next video tutorial. Stay safe and healthy always, mga palangga. Bye!